Good morning, everyone.
Good morning.
Thank you for coming this meeting. This meeting is aimed to design a more suitable object detection model for our new system, which is the autonomous driving system. So our claim is simple but demanding. The system need to provide the real-time performance but no latency. So to track off with the accuracy and speed, Choon Fei, can you start with your assessment?
Yes, sure. Based on my past experience with working with different machine learning models, I find out that faster RCNN can be an attractive option for us, especially in object detection for ADS. Why I say that? Because it has a two-stage network, where the first stage is focusing on the RPN, the region proposed network, where it will generate the proposed region and then it will find the potential objects before even doing the classification task. And the classification task will occur during the second stage, where it will classify the proposed regions and then it will refine on the boundary boxes it draw for each of the objects detected. Therefore, it able to provide an overall more superior classification capability and also translate into a higher mean average precision.
Okay.
Which in our case, we want to do the object detection model. We want to favor higher precision, and this technique is often unmatched in that perspective. Yeah, what do you guys think?
Alright, I think your idea and explanation is quite good, but let us hear others' opinion first. Mang, how about you? What is your opinion about this?
Actually, I have another suggestion. My suggestion is we use the YOLO method.
Okay.
YOLO method is a single stage architecture. It uses the convolutional neural network to analyze the entire image, and it divide the image into grid, and for each of the grid, it will predict the bounding box and the class probabilities simultaneously. And in terms of the accuracy and the performance speeds, it able to achieve the balance, which means that it can work in the 40 to 50 fps in the real world scenario. Since that our project need to focus on the real time scenario, how about your
Speed.
speed?
To be honest, for faster RCNN, speed can be issue sometime because based on my past project, they all managed to yield the FPS count around 5 to 15 FPS, which is kind of slow.
Yeah.
But we can counter this with the usage of better hardware or with better CPU, GPU, and also better infrastructure.
Okay.
And by doing that, we can manage to even boost the FPS of the faster RCNN. Yeah.
Okay. So what's the budget actually for this project?
Good question. So for your information, the budget for each vehicle is around 450k, including the cooling system, camera, and so on.
Okay.
So if we need to run the faster RCNN, we need at least 2 GPU.
Okay.
So GPU such as NVIDIA A100, it costs about 35k to 70k
70K.
for each. So if we use these two graphic card in our implementation, the cost will increase until 550k to 700k. So it already exceeds our budget. But however, for the YOLO algorithm, you can run it in the graphic card such as RTX series. It costs around 3k to 7k only for each.
Okay.
So in this case, I think for our system, the faster RCNN is not an ideal solution. I more prefer, in my opinion, the
YOLO.
YOLO
because it's cheaper.
Yes. How about you, Shannon? What is your suggestion?
I think so. If you ask me, maybe they still have some points to finish off, because I think so their assessment was also a bit halved. So I think so maybe after they complete their own assessments, because so far I've seen that they only discuss about the architecture and the precision, maybe they have more to add on. So maybe after they complete each of the assessments, we can compare, and if it really falls down to having to increase the budget, then maybe I can request the board of directors to increase the budget, because at the end we want a solution that can actually solve the product, which is the ADS. So maybe we can let them compare first. We can compare, let them assess their own things first.
Okay, understood.
So I know we have a massive concern with the speed of the model itself, but how about the accuracy or the precision of the model? Because I read online, it shows that YOLO often have sacrificed their accuracy and also precision. And when it comes to our case, when we want to build an object detection model, does YOLO able to deliver on the precision part?
Actually, for the modern YOLO version, such as the YOLO V11,
Okay.
it can achieve around 55% of the mean average precision on the Coco dataset. That means it can be able to work in our system well,
Okay.
and it's not enough for us.
Sorry to interrupt. What is Coco dataset actually?
Coco dataset is the widely used benchmark for the object detection models. It contains around more than 300k of the image object and more than 80 of the object classes. And each class, the classes include the person, bicycle, and the car, and others.
Okay.
As can be commonly seen in the road also. And with each image, it have the detailed annotation such as the bounding box and the key
Label.
point inside the image. So it's the widely used for the evaluation of the performance of the
Ones of the
models.
Okay. Okay.
Okay, Fei, did Manyong answer your question?
Yes, very clear. Thanks.
Okay, then I think this is a good discussion. So Shannon, what conclusion you can get from our discussion?
So I think so, based on what I heard from both of them just now, I can sort of summarize of what each of them assessed on their model. So if I want to start with what Choon Fei said, his assessment was based on a technique called faster RCNN. So his technique, it focuses more on the precision and the accuracy, which means it's concerned more with how much of quality it can deliver through the object detection, but it is still lacking in the part of speed, because as he said, through research he found out that a faster RCNN can only achieve 5 to 15 FPS, but in terms of accuracy I do understand it's far more superior. But as I think so Hui Xin previously mentioned, our project is more towards real-time implementation, and we want a solution that can detect objects in a very fast rate. So in terms of that, even though accuracy is one of the factors, we prioritize the speed more. From that perspective, I think so what Manyong suggested, the approach of YOLO, I think so is more feasible to be used in our project, because it's also well balanced. The accuracy is also not bad, and I think so he said 55% MAP. I think so it can be further improved with more fine tuning. Maybe you can find your own data and things like that. And the speed of having 40 to 60 FPS you said just now, right? I think so is very good. I think so it gives what we need for our ADS project. So in that term, I think so we can go on with Manyong's approach of YOLO for delivering this ADS. So for formalities, Choon Fei, are you okay with signing off this project to Manyong?
Yes, sure. Even though I still prefer the precision provided by the faster RCNN, but I can see that YOLO is a more viable
Okay.
outcome, because it provides a higher capability, generating a higher FPS count. So I think we should proceed with YOLO.
Okay. Okay.
Alright, I agree with you. guys, let us move forward to YOLO algorithm. So may I ask what we need to prepare before we schedule for our next meeting?
What's the next step, Monyam?
What is the next step?
For the next stage, we need to specify the YOLO version first, and then we need to determine the development environment tools.
Okay.
And next, we need to find more data about
To fine tune.
to fine tune our models.
Okay. So I think so you can prepare all of this and we can maybe schedule the next meeting this coming Friday. So I think so we expect you to prepare all this so that we can move forward. You can ask your team to prepare all these, the tools, the libraries that you said. So we can set the meeting on this coming Friday maybe, and we can discuss further on implementing YOLO for our ADS. Okay.
Okay, then that's all. Thank you.
Okay, thank you.